I'm making this quick video for you in order to show what the expectation is in class for our activity having to do with the fractions pretest, diagnosing and assisting. Remember that there are going to be 4 parts to each problem that you address the class with. And the first is that we're going to mention some positives that we see in the students' work. The second is that we're going to find what went wrong and discuss it a bit, perhaps work out the problem correctly. The third is going to be determine what was at the core of the mistake and see if we can help the student move toward understanding. And fourth, provide some general tips and tricks for the student, just in general. How do I remember how to do this correctly instead of incorrectly? So, it's very easy to look at this and notice what it is that's wrong right away. And that is that clearly 4 1/5 plus 2 3/4 is not the same thing as 20 plus 24. It's just not. But what's behind the student's thinking? And as I consider these numbers and I look for what's positive, it looks to me like the student probably got the 20 from looking at the 3 numbers up here and multiplying 5 by 4 and then multiplying by 1. 5 times 4 times 1 is 20. And for the 24, it looks like the student did 4 times 2, which is 8, times 3, which is 24. Typically, when I give a pretest, the students do not have access to calculators, especially for problems like this, where some calculators can actually work the fractions for you. So this tells me the student knows their multiplication tables. Also, I look at the addition problem, and the student has correctly added 20 plus 24. The student has some understanding of their multiplication tables and their addition facts. However, moving on to what's wrong, as was mentioned earlier, 4 1/5 is not the same thing as 20. Throwing another positive out there though, something else I'm seeing is the student realizes that mixed numbers can be written in a different way and worked with in a different way. But the student took that step improperly. So that's something that the student did wrong. So instead of taking 4 1/5 and multiplying all 3 of those numbers, what should have happened is the student should have multiplied 4 by 5, which is 20, and then added the 1. So we get 21/5. And the big deal is that we need to keep that denominator. That remains with us. That is the measurement that we're working with, whether we've got mixed numbers or improper fractions. And then we see 2 3/4. And here also, we don't just want to multiply. It's 4 times 2, which is 8. And then we're going to add the 3, which is 11. And so we get 11/4. So now we have changed the form. We can go ahead and add, but we will want to remind the student, because this is something we didn't see in their problem. We don't know if they would have done this correctly or not because it just didn't even show up. We do need to get a common denominator. In this case, it would be 20, which we could get by multiplying the first fraction by 4/4 and the second fraction by 5/5. And this gives us 84/20 plus 55/20. And if we add that, we get 139/20. Now, typically, if your problem, just throwing this out here as a hint, typically if your problem starts out using mixed numbers, you should go from here and change this improper fraction that you have as your answer into a mixed number. We're not going to take the class time to go through that as well. We're not teaching everything about fractions. We're just trying to zero in on what went wrong in this particular problem. So it seems to me that at the core of the mistake, so I'm moving on to number 3 here, determine on what the core of the mistake was. It seems like the student had maybe just memorized some rules and knew that they needed to do something like what I was doing up here, and they thought it involved just multiplying and that you just got a single number out of it. So it seems that they don't actually understand what mixed numbers are. So something that I would use to help the student understand more deeply is I would use some manipulatives or some drawings to represent these. So 4 1/5 could be drawn as 1, 2, 3, 4, and then we have some extra here. And we would need to break these circles up into fifths, which is going to be a little hard given how small I just drew this, but I'll do my best. 1, 2, 3, 4, 5. And pretend these units are all the same and that I'm absolutely cutting these up into equal pieces. Hopefully in a classroom, you're going to have manipulative materials that are going to help you do this very precisely. So 4 1/5 is actually all 4 of these filled in solid, 4 units plus 1/5 more. And I would use that in order to talk about how 4 1/5 is the same thing as 21/5, because although I can no longer see my cuts that I made here, there are 5 cuts in each one of these. So I've got 5 plus 5 plus 5 plus 5 plus 1 more, which is 21. And what we're talking about here is fifths. Now I'm doing this quickly with you. You guys are college students, you're going to be teachers. With a child, I would take a lot more time. I would do the same thing with 2 3/4. So we have 2 3/4. We are working with fourths. One circle is 1 unit, one circle equals 1, but each one of these has been split into 4 pieces. And so we could look at this as 2 3/4. Once I fill it in, I'll do it this way this time so we can see the pieces a little better. Everything that's being darkened in is being counted. So I see one whole, and one, excuse me, I need 3/4, don't I, for this problem? I'm in a little too much of a hurry. So 1 plus 1 plus 3/4 is 2/4, and that's 2 3/4, which is one way to see this problem. Another way to see this problem and to connect improper fractions with mixed numbers is to say, well, I've got 4 pieces here, plus 4 pieces here, plus 3 pieces here, and that is equal to 11. And what we are counting is fourths. And that is exactly what we got up here. So that's part 3. What would I use to explain to the student what's really going on and how to go about this? I would use these drawings that I've just done to explain why this process up here is what it is, why I multiply and then I add. I multiply 4 by 5 because each one of these 4 units has been split into 5 pieces. So I have 4 groups of 5, which is 20 plus 1 more, right? I'd really use that picture. And I think the biggest hint I can make here for helping the student understand this and move forward, not making the same mistake again, is I would talk about estimation. Estimation. This is a really important thing in mathematics. We don't want to rely just on rules. Well, I think I just multiply, add, boom, done. I think I remember that being a rule. Well, but let's look at what we're adding. We're adding 4 plus a little more, and then a number that's almost 3, right? Or basically 4 plus 2, each one having a fraction behind it, however you want to go about this. Regardless, you should get something that's in between 6 and 7. It's 4 plus 2, or maybe we want to round up with this and say it's 4 plus 3. So the answer is going to be between 6 and 7. But the answer that the student came up with is 44. So if the student is thinking about their work logically, and if they do some estimation ahead of time, they're going to know that what they came up with is incorrect because it's wildly different from what their answer should have been. So I hope this helps you as you get ready to do your presentations in class.